Every few years, the ocean breathes and the world shakes. Storms intensify, droughts grip entire continents, floods erase coastlines. Billions of lives disrupted by a single quiet shift in sea surface temperature. This is El Niño, one of the most powerful climate forces on Earth, and scientists are still uncovering just how far its reach extends.
To understand El Niño, we start in the tropical Pacific, the engine of Earth's climate system. Normally, powerful trade winds blow westward across the equator, pushing warm surface water toward Asia and Australia. As that warm water piles up thousands of miles away, cold, nutrient-rich water rises up from the depths off the coast of South America, a process called upwelling. The result is a stable, predictable pattern: warm in the west, cool in the east, lush rainforests in Indonesia, dry, productive coastlines in Peru.
But every 2 to 7 years, that balance breaks. The trade winds weaken, sometimes dramatically. The warm water that had been piled up in the western Pacific begins to slosh back towards the east. Sea surface temperatures in the central and eastern Pacific climb, sometimes by more than 3 degrees Celsius above normal. That warming is the trigger. Everything that follows flows from this one shift in the ocean. The name El Niño, Spanish for the little boy or the Christ child, was given by Peruvian fishermen centuries ago. They noticed that a warm current arrived near Christmas, bringing with it poor fish harvests and heavy, destructive rains. What they named a local nuisance, we now understand as a global force. El Niño doesn't just change weather patterns, it rewires the entire atmosphere. Jet streams bend, monsoons weaken, storm tracks shift. The consequences are felt on every continent on Earth.
The effects are not random, they follow a pattern. In the western United States, El Niño typically brings heavy winter rains, refilling reservoirs, but also triggering dangerous floods and landslides. The American South sees milder winters, while the Pacific Northwest and Great Plains often turn dry. Across the Atlantic, El Niño acts as a hurricane suppressor. Increased wind shear tears apart developing tropical storms before they can organize and strengthen.
On the other side of the world, the story is entirely different. Indonesia, the Philippines, and Australia face brutal, prolonged drought. The 1997 to 1998 El Niño triggered the worst fires in Southeast Asian history. Thick smoke blanketed a region the size of Europe for months. In Africa, the east floods, while the south and the Sahel fall into drought. India's monsoon, the lifeblood of over 1 billion people, weakens or shifts, threatening crop failures across the subcontinent.
South America, near the very source of the phenomenon, experiences some of the most dramatic swings of all. During the 1997 to 1998 event, rivers appeared in the Peruvian desert where none had flowed in decades. Green vegetation erupted from sand. But then came the floods, the landslides, and the collapse of fisheries that communities had depended on for generations. The anchovy population, vital to the marine ecosystem and to global fish meal supply, crashed almost overnight. Coral reefs across the tropics bleached and died as ocean temperatures surged past their biological tolerance. That single El Niño event caused an estimated $45 billion in damages and claimed more than 23,000 lives.
Today, scientists can see El Niño coming, sometimes more than a year before it arrives. A network of nearly 70 ocean buoys, called the Triton Array, stretches across the equatorial Pacific, recording ocean temperatures every single day. Satellites measure sea surface height, Even a small rise signals warm water quietly accumulating below the surface. Supercomputer climate models run thousands of simulations to forecast where and when the next event will strike. The Niño 3.4 index, the sea surface temperature anomaly in a critical patch of the Central Pacific, is the key measurement scientists watch. When that index exceeds 0.5 degrees Celsius above normal for 5 consecutive months, El Niño is officially declared. These early warning systems now give governments, farmers, and disaster agencies up to 12 months to prepare. In Peru, El Niño forecasts trigger evacuations, river levee reinforcement, and emergency crop switches. In East Africa, advance warning enables food aid to be pre-positioned before drought reaches its peak. The science of ENSO, the El Niño Southern Oscillation, has already saved countless lives, but significant challenges remain. The so-called spring predictability barrier, a window each year when forecast accuracy drops sharply, still frustrates scientists.
As greenhouse gases trap more heat in Earth's atmosphere, the oceans absorb over 90% of that energy. A warmer baseline ocean means El Niño events begin from a higher starting point and can swing to greater extremes. The 2015 to 2016 El Niño became the strongest on record, rivaling 1997 to 1998, but striking a planet already running a fever. Global coral bleaching events, once rare, are now occurring nearly every decade. Extreme rainfall during El Niño is intensifying because warmer air holds far more moisture. Scientists now ask a question that would have seemed extreme just a generation ago. Are we moving toward a new normal? One where catastrophic El Niños are not rare exceptions, but a recurring feature of our climate? The answer may be written in the ancient ice cores of Antarctica, in the growth rings of fossil corals, and in the sediment layers of the deep Pacific floor. Paleoclimate records confirm that El Niño has operated for tens of thousands of years. But its character,
our climate is breaking, entering an era.
All are shifting in ways that have no precedent in the instrumental record.
The question is no longer whether El Niño will return. It will. The question is whether the world will be ready, with better forecasts, smarter infrastructure, and communities built to withstand what is coming. The nations most vulnerable to its fury, small island states, subsistence farming communities, low-lying coastal populations, have contributed the least to the warming that is amplifying these events, yet they will pay the highest price. El Niño is not new, it is ancient, but our vulnerability to it is, in part, our own creation. Understanding it is not just science, it is survival, and somewhere out in the vast, sun-warmed Pacific, the ocean is already sending its next signal.